For moment experiment, we have the instrument, the apparatus, which is the material for moment. We have meter rule, which is this 100 cm meter rule. We have the pivots, also called the fulcrum or the knife edge.
The whispers in the morning.
This is Her Majesty is a World. Please subscribe and share my videos. Much love from me to you.
Even all of my soul, what I desire is for you. That you
For moment experiment, we have the instrument, the apparatus, which is the material for moment. We have meter rule, which is this 100 cm meter rule. We have the pivots, also called the fulcrum or the knife edge. These are the fulcrum or the knife edge. It can also be called knife edge or pivot. We have the masses here. This is a 20 gram mass, 20 gram mass. This is 10 gram mass, 50 gram mass is 20. We have 100 gram masses here, and our spring balance, and the thread. We have the thread for the experiment. So these are the material, the apparatus that are needed for the experiment, physics experiment on moment. So we will set up the apparatus. We have the pivots. If you are using a lab bench, you can take your pivot to the point so that the masses will not hit the table. Take it to the extreme. To balance, the first thing we'll do is to balance our meter rule to get the center of gravity, G. From the question we're asked to get the center of gravity, G. So we'll balance our meter rule gently. Some of the meter rules might not balance at 50, even though it's 100 cm meter rule, but because of the material, you must gently balance it, gently guide it. Is balanced? No. Let's take it closely. You must be careful to avoid air resistance. The meter rule is balanced at, from this point we have 49.5678. So this is 49.9 here before 50. You have here 0.9 here, 49.9 before 50. 49.9 cm is our G. This is our record. The setup we have. This is the setup we have from the question on the board. You can see the diagram there. The G there represents the center of gravity, and the X represents where the knife edge will balance the moment we hang a mass at 80 cm. M. Once we hang a mass M at 80 cm or any place there, we will take the reading from X to where the mass is hung. Now the question says suspend the meter rule. This is the setup on the board. We have the point 0 cm, the ruler. This is the meter rule, and here is the point of balance called center of gravity. This is where the ruler balances, and the center of gravity from what we have is a 49.9 cm. X is a point where the mass is balanced on the knife edge. X, and this the thread and the mass M. The total length of the meter rule is 100 cm. So let's look at the question. Since we have the setup, suspend the meter rule only on the knife edge to balance it horizontally. The first instruction says read and record the value as G. When you balance it, you get the G, the center of gravity. Now, with the rope, suspend a mass M equal to 20 grams at 80 cm mark of the meter rule. We are going to perform this instruction. The second instruction says that we should hang the mass 20 grams at 80 cm mark of the meter rule. That is what we are going to do now. Let's do that before we come back and take another instruction. This is our mass, 20 gram mass with hanger. Our meter rule is still balanced on a knife edge, the center of gravity. We take the thread. This is the thread. This is the thread here, and we will locate 80 cm. 80 cm. Hang your mass. ATCM. This is my ATCM from this point. My ATCM. Now, since it's at 80 cm, the pivot will no longer balance the meter rule at our center of gravity. So the center of gravity will now change, meaning that we are now balancing it to get our X. Remember, we are hanging the mass, 20 gram mass, at 80 cm, and we are going to find a balance point gradually as it moves out, gradually. At this point, make sure that your mass is well placed on the meter rule, hanging, balance on the knife edge at 80 cm according to the instruction given. You have the instruction, and we are going to consider the new place Okay, so I hope you are viewing very well. So from the balance point here, we have 53, 55, 50 as 57. Make sure you are reading very well. As 57 from there to here is 57, not 55. Here is 55. So we have 54, 55, and 6, 7 at this point. And from this point to this point, we is hung at 80. So we look at the reading of X. Okay, from the setup and the experiment we did, we balanced the meter rule, and the center of gravity, we had 49.9 cm from the center of gravity, and the instruction we have, the first instruction is to hang 20 gram mass at 80 cm. Here, these are 20 gram mass at 80 cm, and our X is 54.7. Our X, when we have 20 gram mass at 80 cm, is equals to 54.7 cm, and the distance between 80 cm and the X is our Z, meaning that our Z is equals to 80 minus our X, which is equals to 25.3 cm. Remember to always put units on the table. Once you write Z as a variable to be tabulated, add the unit as in cm. Whatsoever we are doing, there must be cm on your table. So this is the first experimental process. So we have 25.3 cm as our Z. Having gotten our Z, we will now look at how to get our M. To evaluate M, M is equals to X minus G. Remember, the G is the center of gravity, where the ruler, the meter rule, is balanced, while X is the point at which the 20 gram mass hung at 80 cm balances, and since our G is equal to 49.9 cm, our X, the balance point, is 54.7 cm. Our M is equal to X minus G, giving us 54.7 minus 49.9, which is equal to 4.8 cm. Remember, the evaluation is based on our M being 20 gram mass, and at the point where its hang is 80 cm, which is the constant point of hanging the masses. Our Z is known, our N is known. The next is our N. How do we know our N? The mass is 20 gram. We have 20 gram mass, which is M. Then our Z, so you times the mass with our Z. Our Z is 25.3. So you now say 20 times 25.3. You get your M. From our evaluation, we have M representing mass, which is in grams, and our Z is in cm. So the unit of N is going to be gram cm. Gram cm. So on top of your table, where you tabulate your reading, you write N is equals to M times Z in brackets gram cm. That's the unit for M. Remember, the unit for M is cm. The unit for Z is cm. Okay. Repeat the entire procedure by hanging 40 gram mass on the meter rule to be balanced on the knife edge. Remember, we have 20 gram here already, and so we are going to add another 20 gram to the mass we have already hung on the meter rule. I'm adding 40. Now the balance point will change. So this is 40, and remember, you will not shift the thread or the mass out from 80 cm. It must be on 80 cm. The hanging point must be on 80 cm. 40 gram mass. Let's consider the balancing point. We move on. We're about to take our second reading from 40 gram mass hanged at 80 cm. Remember, the ruler have double calibration, and we are using from this point. From here is 0, and you read through to 100 cm. That's the first calibration here, and the second calibration down is the same cm, but that is not what we are using. So make sure you know where you are hanging your mass on and maintain that calibration. This is where we hang our own at 80 cm. If you watch very well, this is 80 cm, and the second calibration is 20, so don't mistake it from the first one. This is the one we are using here, 80 cm on the meter rule, and our balance point is here. We have this is 58.1 cm. Make sure you it is not up to 58. If you watch very well directly, you will see that we have 57.9. Let's take 0.9, but because it's a physics experiment, you must view very well. You must stand directly and view it very well. It is not exactly at 58. The knife edge is, yes, this is a 57.9 cm. Don't make mistake, but remember, it's an experiment. Yours can be different from mine, and the ruler you are using might be different. The center of gravity determines where the mass will balance. Okay, we will now consider the evaluation of Z in tabulating the second experimental process. Z. Okay, like I said, in our second experiment, when M is 40 gram, is balance X is equals to 57.9 cm. 40 gram mass is balanced at 57.9 cm. So we'll now evaluate our Z. From what we have on the board, remember, in our second experiment, we repeated the procedure with 40 gram mass, and 40 gram mass balanced at X is 57.9. Now our Z, in evaluating Z is equals to 80 minus X. So 80 minus 57.9 will give us 22.1 cm. So we record 22.1 cm when 40 gram mass is held at 80 cm. Don't forget. And our M, to evaluate our M, which is M is equals to X minus the G. G is the center of gravity. G is our M. M is equals to X, which is 57.9 minus our center of gravity, 49.9, giving us 8 cm. M is 8 cm. What is our N? Remember, from here, our N is equals to M times Z. and the value of our Z is 22 this is N here. We look at the 40 gram mass times 22.1, which is 40 gram mass there with the value of Z 22.1 times 40 gram. We have 884. 884. Remember, is gram cm when you are recording it on your table. So this is the value of our N. We will take the third procedure on 50 gram mass, and we will now consider how to get the remaining on your own. At 50 gram, we have X balanced at 59.1 cm, while our Z is at 20.9 cm. Our M is 9.2 cm, and we have 1045.0 gram cm. So we can go on and balance the point gram, 70 gram mass, 80 gram mass, and 100 gram mass. But remember, our center of gravity, which is Z, is 49.9 cm. Don't forget, your center of gravity must be written on top of your table, indicating the center of gravity of the 100 cm meter rule. So from our tabulation, remember to put your units. Each column have units. The variable should have units. Don't forget. And fill your table. After filling your table, under tabulating your readings, the next instruction we are given is to plot a graph of N on vertical axis against the graph of M on the horizontal axis. The graph of N, this is our N here, vertical axis, and our M is here on horizontal axis. You can be asked to plot anything against anyone, but be careful to carry out the instructions. You don't assume anything in physics experiment. You must read the experimental procedure and the instructions carefully so that you will not make mistake. If the values are if the values are big, you can raise those values to standard. You can raise it to standard form. And once you raise it to standard form, write what you raise it to on top of your table. If you are raising 560 to one decimal place or two decimal place, you can write times 10 raised to power minus 2. Take for instance, if you have 506 and you feel that the value is too big, you can reduce this value by having 50, or let's say 5.06 times 10 raised to power. You know, if it's minus 1 or minus 2 or minus whatever, but this times 10 will be written on top of the table where you raise it. Where if you raise it, you write it on top of the table so that the examiner or the marker will know what happened to 506 that you reduce this so that you can plot the graph.
Yes.